A nice, relaxing, simple exercise this time. So say you have a function and that function turns out to be an eigenfunction of two different operators. Now in that case, can you show that if you let loose the commutator of these two operators on that eigenfunction, that the end result is 0? Pause the video and try and convince yourself of this fact. Let's see what we know. We know that we have a certain function h, which is an eigenfunction of an operator. Now let's call that first operator capital theta. So if capital theta operates on h, we get back that same function h, but multiplied by an eigenvalue. We also know that that very same function h is also an eigenfunction of a second operator, and let's call that second operator O. So again, if O operates on h, we get back h times an eigenvalue. Now obviously, it's very possible that the eigenvalue here is different from the eigenvalue upstairs there. So we use a different value, let's call that one alpha. Okay, that's a starting point. Let's now have our commutator operating upon h. So the commutator of theta and O operating upon h. It basically means that we have theta O h minus O theta h. And now it's very simple. Let's just focus here on the first step. So these operators operate from right to the left because the first operator that the function h encounters is, of course, in this case, O. O of h, we know that O of h is alpha h. So this becomes now the operator theta operating upon alpha h. And then minus, we have the operator O operating upon theta h, but by virtue of the fact that we're dealing with eigen problems here, theta h, as you see up there, theta h is lambda h. So O of h operates on lambda h. These eigenvalues alpha and lambda, they're just boring scalars, and since we're dealing with linear problems, we can move them safely outside of the operators. So in the end, we have alpha times theta operating upon h. So theta operating upon h is lambda h. And then very similar, we have lambda and then alpha h. And trivially, that indeed reduces to 0, which is what we were after.